Let's discuss ground fault circuit interrupters, or GFCIs, specifically in relation to multi-wire branch circuits and their neutral connections. The question revolves around a situation where receptacles on multiple phases, designated as A, B, and C, are wired on branch circuits that incorrectly share a single common neutral. Each of these circuits is protected by a GFCI breaker. Crucially, the neutral conductors of these circuits were improperly connected, or jumped together between the GFCI breakers, resulting in nuisance tripping of the breakers. The individual wants to know if there is a trick to overcome this problem and still achieve GFCI protection. The answer is definitively no. There isn't any wiring manipulation or trick that will allow GFCI breakers to function correctly on a multi-wire branch circuit with a shared neutral. The fundamental principle of GFCI operation relies on sensing an imbalance between the current flowing through the hot conductor or phase conductor and the neutral conductor within that specific circuit. GFCIs measure the current in the hot and neutral conductors. If the current flowing out on the hot wire does not equal the current returning on the neutral wire, a ground fault is detected and the breaker trips, interrupting the circuit. When multiple phase circuits, such as A, B, and C, share a single neutral, the return current on that neutral can be the sum of the imbalance load currents from all three phases. A GFCI on any one of these phases will not be able to accurately determine if a ground fault exists on its specific circuit because it cannot isolate the current flow from other circuits sharing the neutral. The current imbalance it detects might be due to normal load variations on the other phases, rather than an actual ground fault on its own circuit. This is why the breakers are tripping erroneously. The only correct and safe solution is to rewire the circuit. Each phase, A, B, and C in this instance, must have its own dedicated neutral conductor that runs independently back to the neutral bus bar in the electrical panel. This ensures that each GFCI breaker monitors only the current flowing in its own phase and neutral pair, allowing it to accurately detect ground faults on that specific circuit. Attempting to fake out a GFCI breaker is extremely dangerous and could eliminate ground fault protection. Ground fault protection is designed to protect people from electrical shock hazards. Tampering with the wiring to bypass this protection could result in serious injury or death.